Okay, topic today, law of cosines. First of all, we're starting a new unit on oblique triangles. Oblique triangles. An oblique triangle is basically any triangle that does not have a right angle. Okay, in what ways can we use trig to solve them? Well, we can use the law of cosines, we can use the law of sines, we can find the area. There's all kinds of things that we can do with oblique triangles here. All right, what is the law of cosines first of all? All right, and even before I get into that, I apologize. Let's talk about a little bit how you name triangles. And you notice I've got a capital A for the angle, and then on the side across from that, the opposite side is the lowercase a. And that's convention for naming sides and angles of any triangle. So when we see the law of cosines, it kind of reminds me of the Pythagorean theorem, c squared equals a squared plus b squared minus 2ab cosine c. This formula is provided for you on the Regents exam, but it's really not a difficult one to remember. Okay? Law of cosines. When do I use it? Well, obviously I have like 3 sides in there, and I have an angle in there, so I can use it to solve for any one of those sides or an angle. Because if I know 3 out of the 4 things, the fourth one can be solved for. When you are given all 3 sides, you can solve it and find an angle. Or when you're given side, angle side, which is 2 sides and the angle in between them, you can use the law of cosines to solve. All right, procedure. Draw and label a triangle. Plug info into formula and solve for what the question asks for. All right, so triangle PQR. We're going to draw triangles, and they don't have to be. This one looks almost like an isosceles triangle. It's not drawn to scale. That's not what's important. What's important is getting your angles labeled and then writing in the sides where they should go. Like, for example, 4, here r equals 4, that should go across from angle r. And then q equals 5 should go across from angle q. This time they don't tell me what p is. They tell me what a cosine of p. All right, so we're talking about this angle. I'm not going to label that -2/5 because p doesn't equal -2/5, but I do know what the cosine of p is. They want me to find little p in simplest radical form, so this is this guy here. Okay, the law of cosines always has one angle that we're dealing with. The side across from that is the one that's sitting there by itself in the law of cosines. Reminder: c squared a squared plus b squared minus 2ab cosine c. All right, and the loneliest side is this c sitting here by itself. That's the one across from the angle that we're going to use. So in this case, my loneliest side here is p. All right, and then the 4 and 5, much like the legs in the hypotenuse, the legs in the Pythagorean theorem are interchangeable. Okay, the important one is the hypotenuse. Well, in this case, the important one is the loneliest side. It's the one across from the angle that we're taking the cosine of. Now, I didn't substitute in for cosine p. Kind of want to prove a point here. This is not cosine of -2/5. Okay, and I've seen I don't know how many times when they tell you cosine of p equals -2/5, some students will write cosine of -2/5, and that's not correct. P is not -2/5. The entire expression cosine p is -2/5. So you're going to basically, right, some of these are a little rudimentary here when we're starting. These are kind of basic ones. All right. And then it's really just arithmetic from here. 4 squared is 16 plus 25. And I hope you recognize that if you have a 5 and then you're dividing by a 5 here, right in the same term, you can cancel those out. You get positive 16 when you multiply -2 times 4 times -2. Okay, so 16 and 16 and 25, p squared equals 57. Take the square root of both sides to find p. Don't worry about plus or minus here because we're talking about the side of a triangle. And there are no perfect square factors. We don't have any radicals in the denominator, so that is in simplest radical form. P equals radical 57. All right, and again, if I'm going too fast, you can always pause the video or rewind it. Okay, triangle ABC. Triangle ABC, A, B, C. Little a is 6, little b is 10, and the measure of angle C this time is 120 degrees. Obviously, that's not a 120-degree angle, but again, it doesn't have to be drawn to scale. Find little c. That's going to be across from the angle C. There we go. So that's my loneliest side because that's the angle that I'm going to be using for the law of cosines here. C squared equals 6 squared plus 10 squared minus 2 times 6 times 10 times the cosine of 120. And once you get the stuff plugged in, take a second, look back at what you're given, make sure you've labeled things correctly. Little a is 6, so that should go there. Little b is 10, that should go there. And the measure of angle C is 120. And make sure you have everything plugged in okay. Because really, that's kind of as complex as this one's probably going to get. Let's see, well, you do need to know the cosine of 120, but I think we've done that several times this year. So that's going to be negative 120 when I multiply those times the cosine of 120. So that's a second quadrant angle. Let me draw a 120-degree angle in standard position. Again, a sketch. All right, I don't know that that's 120 degrees. That certainly doesn't look like it, but my alpha is 60. What's important is I've drawn it into the second quadrant, and I understand that cosine in the second quadrant is negative. So this is going to equal the negative cosine of 60. Use those special right triangles, and that's going to be negative 1/2. All right, so that gives me a plus 60. 36 plus 100 plus 60. C squared is going to be 196. Get the square root of both sides. Oh, that's perfect square. C equals 14. I love it when it works out nice like that. All right. Doesn't always, though. Okay. Again, moving quickly. If you're having trouble, pause, replay. All right, rewind, go back. D, E, F. D, E, F. All right. Little d is 15. Little e is 11. And the measure of angle F is 60 degrees. All right. So now, this is very, very, very similar to example number 2. I'm supposed to be finding little f here. So little f goes there, and that is across from the angle that I have the 60 degree for. So f squared equals 11 squared plus 15 squared minus 2 times 11 times 15 times the cosine of 60. All right, so f squared is 121 plus 225 minus, I have 2 times 11 times 15 times the cosine of 60. All right, so you can do 2 times 11 times 15, certainly. And 2 times 11 times 15 is 330. And then the cosine of 60 is from our special right triangle is 1/2. All right, so I need to do the half of 330. This is 165, and 121 plus 225 minus 165 is 121 plus 225 minus 165. I'm using the calculator to kind of try and speed this up a little bit so I can get the whole thing in, in 15 minutes. All right, so I've got f squared equals the 181. You take the square root of both sides. All right, and then you have to think a little bit to see, are there any perfect squares that go into 181? Now you can check 9 because 1 plus 8 plus 1 equals 10. And if it was divisible by 9, it would have added up to 9 or a multiple of 9. So it's not divisible by 9. You can check, any of them. All right? That is the answer in simple radical form, 181. Okay, example number 4. This time they want me to find cosine t. Triangle RST, they give me 1 side, 2 side, they're giving me all 3 sides. So this is an example where you're given all 3 sides. Little r is 7, s is 10, and t is 15. They want me to find cosine t. So that means I'm dealing with this angle. All right, that part about it, finding cosine t, made 15 the loneliest side. If I wanted to find cosine of r, well then 7 would have been my loneliest side. But as it is, poor 15 over here by himself. Alright. Alright, so the cosine of t. There's cosine t sitting in there. That's what I'm going to want to try and solve for here. So I have 100 plus 49, and that's going to be minus 140 cosine t. And this side over here is 225. So 225 equals, let's see, can I combine all of this and get 9 cosine t? The answer to that is no, okay? This one right here is not like terms with these other two. These guys are like terms. I can combine those happily, but I can't combine that here, And it's very tempting for students to want to subtract that, but they're not like terms. What I have to do, in fact, is actually subtract 149 from both sides. Okay, you get 76 equals a negative 140 cosine t. All right, and now I can see how to solve for cosine t here. Divide both sides by negative 140, and I am going to get negative 76 over 140, which when you reduce that gives you 19 over 35, and it's going to be negative 19 over 35, which equals cosine t. So what does that tell you about t? If the cosine is negative, is it going to be obtuse or acute? It's going to be greater than 90, and in the second quadrant, because it's a negative. All right. Question 5. You know, question 5 I think I'm going to leave as an exercise for you because, well, it's very similar to questions 2 and 3. So I'm going to leave 5 as an exercise for you to do for class tomorrow. All right? Go back and watch the video on examples 2 and 3 if you want some help. All right, well now moving forward here, we've got something that reminds me of geometry. It brings back some geometry, some of the stuff from last year. All right, and basically I want to find x and y. All right, well, here we have a tangent, right, and here we have a chord, secant. So it's 10 squared equals 5 times 5 plus x. All right, so you've got 100 equals 25 plus 5x. 75 equals 5x. You divide both sides by 5, and you get 15 equals x. So that's 15. So now that I know 15, actually, I have 10. I have 20, and I have 12. I actually have side, side, side. So I can use the law of cosines to find angle y. Okay, so this, again, this whole side is 20. All right, so which one's the loneliest side? We're trying to find angle y, so this is the angle I'm focusing on. I look across from that, and that gives me the loneliest side of 12. So 12 squared equals 10 squared plus 20 squared minus 2 times 10 times 20 times the cosine of y. All right, we'll pick up the pace a little bit here. 12 squared, 144. 100 plus 400. A minus, that's going to be another 400 cosine y. So this is 500 minus 400 cosine y. 144. So what I need to do is take 144 and subtract 500, and I get negative 356 equals negative 400 cosine y. I'm going to divide both sides by negative 400. Both sides by negative 400. And then I get the cosine of y equals, I'm not even going to bother to reduce this because I'm going to use my calculator to find y here. So that's going to equal the arc cosine of 356 over 400. All right, so let's see. That's going to be second cosine, 356 divided by 400. And I've got y equals 27.12675.312. I'm writing all that down because I didn't read the directions all the way through. That's my fault. Just says find x and y. So I can say to the nearest degree, y equals 27 degrees. Okay? If I went to the nearest tenth, it would be 27.1, and so forth. Okay? So, tomorrow in class, we will be discussing law of cosines and kind of when you can use it. And we'll be expanding on that later tomorrow in class as well. All right, and I'll give you some practice problems to do that. So for class tomorrow, please make sure you attempt to do number 5 on your own. Okay, look back at the earlier in the video, check your notes. Okay, good luck. I'll see you tomorrow. Thanks.